In this video, we will talk about trigonometric substitution. And as you can see here, I laid out the basics of what you need to know for this unit. So on the left side, we have expressions, and these are the expressions that you will need for each substitution for when you have to integrate. I know this might seem confusing, but I will show you how very easy it is to do this. All right, so here we have our first problem. And immediately when you see something like this, you're going to look back at the trigonometric expression for this. So when we look back, out of these three, which one looks similar to this? So immediately we can tell that the first expression looks similar to this. So you can have this as a reference. So a squared is the a will be 1 because a and a squared will just be 1 because 1 squared is just 1. So the a will be 1 and the x squared would be x squared, so we have to leave it like that. Next we have to find the x corresponding. So since we use this expression, now we have to look at this substitution. So the x in this case would be a sine theta. So x would be a sine theta. In this case, it would be just sine theta. So now we're going to plug in our x to the values. Leave the a and plug in the sine value. And we will be left with 1 minus sine squared theta. And we know that cosine squared is equal to 1 minus sine squared, as you can see from the identities. So this would be equal to the square root of cosine squared theta. And when you square root a square, it will cancel out. So this would be cosine theta. And this makes it much more simpler for us. So now we have to go back to our original problem. Let me just rewrite this here. And we can substitute. Oh yeah, since we have x would be sine, as from given from here, we have to derive it in order to get dx. So the derivative of sine theta is cosine theta. So dx would be equal to cosine theta. Plug in a new value in which we got from over here. So this would be x to the power 3 over cosine theta, and dx would be cosine theta since we got the derivative of sine. And as you can see here, we could cancel these out, and we were left with x to the power 3. And we know that x is equal to sine, so it will be sine to the power of 3 theta. And we can use our trigonometric identities. So in this situation, since the sine exponent is odd, we have to take a sign out. So this would just be sine theta sine squared theta. Sine squared is 1 minus cosine squared. We can plug in u substitution. So for cosine, this will give us negative sine theta. Take out the negative, you'll get sine. Bring the negative out from the integral, and the du would be sine. And we would have this as a u. So here's what it looks like. Now we have to integrate it. So this will be simple integration. So now we have to integrate it. So the integral of 1 is u, and the integral of u to the power of 2 is u to the power of 3 over 3. We have to multiply it by negative 1 since we left the negative 1 out of the integral. So this will become negative u plus u to the power of 3 over 3. And now we have to do something very different. So when you're doing trigonometric substitution, you always have to sketch a right triangle. And we have to refer back to the x. So our x was originally sine theta. And as you can see here, sine is equal to opposite over hypotenuse. And we have sine is equal to x over 1, which is the opposite over hypotenuse. So this is the right triangle. And the opposite of the adjacent side, where the theta is going to be right here. The x will be here. And the one is the hypotenuse, which is always the slanted side. And what about the adjacent side? So we have to refer back to our main problem here. It's going to be square root of 1 minus x squared because it's just always going to be that. So this will be 1 minus x squared of the square root. And we know that our u is cosine, is equal to cosine. So we have to put u cosine theta plus cosine to the power of 3 theta over 3. And when we're trying to find the actual value, we could just simply look at our right triangle. So in the triangle, the cosine is equal to adjacent over hypotenuse. So as you can see here, the adjacent would be the square root of 1 minus x squared over 1. So it would just be square root of 1 minus x squared plus 1 over 3, 1 minus x squared to the power of 3 plus c. Alright, so I did a mistake here. So this is me from the future. This is supposed to be the square root of 1 minus x squared to the power of 3. So I just forgot the square root. So yeah. And this is our final answer. And I know this was a very long process, but I'm going to show you an easier example. Now let's take a look at this example. So we have the integral of dx over the square root of 4 plus x squared. And from our table, we can see that the equation that corresponds with this is going to be a squared plus x squared. And the substitution is going to be x equals to a tan theta. So let me write it down. So it's going to be a squared plus x squared. And the substitution would be a to, or x to a tan theta. So what is the a in our equation? We can set these equal to each other. First glance, you might think that the 4 is going to be a. Trust me, guys, it's not. And I'll explain it because 4 is already squared. You don't have to square it anymore. So there must be an original a. So we know that the original a has to be square rooted. So this is more simpler because this matches what the expression is. So the original a is going to be 2. As you can see, it has a square and the a is squared as well. So a is going to be 2. And the x is going to be a tan theta. So we already know the a, so it'll be 2 tan theta. We have to plug in our values. So a squared plus x squared would be 2 squared. If we square these, it would be 4 plus 4tan squared theta. And immediately we can take out the 4. So this would be 1 plus tan squared theta. And we know that 1 plus tan squared theta from our trigonometric identities is going to be secant squared. So 1 plus tan squared is going to be secant squared. And when we square root these individuals, we can think of it like this. This will be 2. And the square root of secant squared is going to be just secant because we take out the square. So we are left with 2 secant theta. So the next step is we have to rewrite our problem. So here we have dx square root of 4 plus x squared. And we know that x is 2 tan theta. The derivative of that is going to be 2 secant squared theta. So let's bring this down and plug in our values. You can cross out the 2 and secant squared theta divided by secant squared is going to be just secant. So we are left with the integral of secant theta. And the integral of secant theta is not like many other integrals of the other trigonometric functions. So in this case, the integral of secant is ln secant x plus tan x plus c. And since we have our final values, we have to put in the right triangle again. Let's look back at our x function. So x is 2 tan theta. We can divide this by 2. We are left with tan theta. And from our right triangle, tangent is equal to opposite over adjacent. And in this case, tangent is equal to x over 2. So the opposite of the theta would be x, and the hypotenuse, or the adjacent, would be 2, as you can see here. And as always, we can put this value as the final slot, because that's how I like to do it. So we are left with ln secant x plus tan x plus c. And secant x is going to be equal to 1 over cosine x. And remember that cosine is equal to adjacent over hypotenuse. So in this situation, it will be 1 over 2 over the square root of 4 plus x squared. We can multiply the reciprocal. So it'll just be square root of 4 plus x squared over 2. So secant is equal to the square root of 4 plus x squared over 2. And now we can plug it in for our final answer. 4 plus x squared over 2 plus tangent, which is what we got over here, x over 2 plus c. This leaves us with our final answer. Now let's take a look at this problem. So right off the bat, we can see that the square root of x squared minus 81 is going to be the key for this problem. So let's look back at our trigonometric substitution. So here we have our trigonometric substitution for reference, and you can see that it's going to be this expression, the square root of x squared minus a squared, and our substitution is going to be x equals a secant theta. So let me put the expression. Set these equal to each other. In this situation would be 9, because 9 squared is going to be 81. So the a would automatically be 9. So now the x would be equal to 9 secant theta. So now we can plug this in for the problem. So x squared would be 9 secant theta squared 81, 81 secant squared theta minus 81. We can take out the 81, so we can have secant squared theta minus 1. And secant squared theta minus 1 is equal to tan squared from our trigonometric function. So this will be equal to 81 tan squared theta square roots. And when we square root both of these, the square root of 81 is 9, and the square root of tan squared would just be tan. So we are left with this. And we can plug this into our equation here. Also, we have to derive the x. So our x was 9 secant theta. The derivative of that is 9 secant theta tan theta. Because the derivative of secant is secant theta tan theta. So we got our dx and we have our problem set up. So our new problem would be 9 secant theta tan theta over 9 tan theta. And immediately we can take out the 9, we can take out the tan, and we are left with the integral of secant theta. And we already know that the integral of secant theta is ln secant theta plus tan theta. And for reference, our x was 9 secant theta. We can divide by 9. So our secant is equal to x over 9. And secant is equal to hypotenuse over adjacent. So in this case, x would be the hypotenuse, and 9 would be the adjacent. And this would be the final missing slot. Again, our final values. Now let's plug in our final values. So this would be ln secant x would be x over 9 plus tangent is opposite over adjacent. So the opposite would be square root of x squared minus 81. The adjacent would be 9 plus c, and we are left with this as our final answer. Guys, this is all you need to know for this unit. So whatever you got to do, take a picture, write it down. This is literally all you need. This is like a cheat sheet for you, so make sure to use it. And that's it, guys. That's pretty much it. All you got to do is practice. Like, just practice, practice, and you'll be set.